So in example 2, we want to find the position of our object from its displacement. So if you suppose that the initial position of the particle in example 1 was s of 0 equals 9. So when time equals 0, our particle is 9 units to the right. Okay, that's where it starts, and then it does its movement, right? So if we want to find that displacement, this is what we talked about just a minute ago. We're going to take the integral from 0 to 1 of v of t dt. And so the second line here, this is just our function, right? We're just substituting the, whoops, sorry about that, hold on. We're just substituting our function in here. So we're going to take the antiderivative of this. So the antiderivative of the first part, that's just our power rule, right? The second part of this, the antiderivative of 8 over t plus 1 to the 2, you can think about using some u substitution here. That's a negative 2. U would be equal to t plus 1, and du would just be equal to 1. So this is really a pretty simple antiderivative to do. It's just going to be 8 times t plus 1 to the negative 1. If we put that back over 1, if we move this back to the denominator, that's just 8 over t plus 1. That's how they got that's how they got this part right here. Right? So then notice the notation that they use here. Once they found the antiderivative, the integral sign is gone. They're putting our antiderivative inside of brackets, and they put this little 0 and 1 out here because that tells us where we're going to integrate it from. The first part of the question here asks what the particle's position is after 1 second. And so that's why they're doing the integral from 0 to 1. So if you substitute 1 into this and then subtract what you get when you substitute 0 in, this right here is the 1 part of that, and then the 8 is the 0 part. And so the displacement is negative 11 over 3. But remember, our particle was already at 9. So if we add our 9 and our negative 11 over 3, our particle's at 16/3, right? To answer the second part of the question, the only difference here is that our upper limit of integration is 5, and so we do that calculation and find out that our particle is now 44 units to the right.